Okay, guys, this is the recorded notes for seniors that'll be missing. Hopefully you can follow along. If you have any questions, of course, come see me in tutorials the next day. But try your best on the homework and see what you can get. Okay, so we're going to keep going on solving logarithm equations. We're going to focus on one type of equation today, just one. And the process will sound familiar to you. Okay, so this is when we're going to take the log of both sides. This is a particular strategy. We use this when we have an exponential equaling another exponential. Now, we've done these type of problems before, last section or last chapter, but we could always change the bases to be like bases. So for instance, if we had 2 to the x and 8 to the x, we could always change that as a power of 2. But what if it was 5 to the x? Well, we cannot make 5 be a power of 2 or 2 be a power of 5. So this is the case where we would use this strategy. We're going to take the log of both sides when you cannot do like bases. Okay, so the first thing you do is exactly what it sounds like. You're going to take the log or natural log of both sides. It really doesn't matter. Either one will get you there. I tend to do the natural log just because it's less to write. But it really does not matter, whatever you prefer. You're going to distribute things out. And this is the step that should sound familiar. Get everything with an x on one side and everything else on the other. Okay? And then factor out an x. Now, we just did that in 5.1 when we did inverses. Remember, all the x's go on one side, everything else on the other, factor out an x. The exact same process we're going to do. Now, this is the step that a lot of people forget, so I'm going to star this one. This is perhaps the most important one. We need to clean up with our log properties. We're going to try to condense things. And then finally, you divide. So these are long problems, and it's going to be confusing at first. But once you do 2 or 3, you'll start to get the hang of it, and you'll see that every problem is very similar. Okay, they're all going to be the same steps. Okay, so bear with me as we kind of do a few. Okay, so looking at this, I cannot get like bases. So I'm going to take the log of both sides. I'm going to do the natural log. Whatever I do to one side, I have to do to the other. Okay, now the property of logs say I'm allowed to power that exponent down. Now when you do that, remember it's multiplication, so you need parentheses there. Now the next step says to distribute. So natural log of 2 is times both of these terms. Natural log of 3 is times both of these terms. So do not multiply something that's not in a log with something that is. We simply write that as 4x times natural log of 2. Don't give me natural log of 8x. You cannot multiply the input of a log with something that's not in the input of a log. Okay. Then minus 1 times natural log of 2 is just natural log of 2. 1 times natural log of 3 is natural log of 3. X times natural log of 3 is simply x natural log of 3. So essentially kind of writing it in front of each term. Okay. Now I see that these two terms have x's, but the other two do not. So my goal is to group these two and then the other two on one side. Now we have to be smart about this, and I talked about this when we did inverses. Try to keep things positive. With inverses, it didn't matter too much, but with logs, it does. Because those negatives really mess with our properties of logs later on and can make them really difficult. And introduce fractions and reciprocals when we don't want to. So I'm going to add x natural log of 3 to this side. And then I'm going to add natural log of 2 to the other side. So now I have all my x's together and everything that doesn't have an x on the other side. I'm going to factor out an x. Okay, and this is the part that's the most confusing to people. Before we divide, you can do it now or you can do it after you divide. It really doesn't matter. I'm going to clean this up. I'm going to clean up here, and I'm going to clean this up. Oh, and I made a typo here. Let me fix that. That's a 2. Okay. So when I clean this up, I'm going to use properties of logs. Remember, I power up first. 2 to the 4th is 16. Now, adding in properties of logs, means I multiply the insides. Let's see, I get 18, and 1, 48. Same here, I'm adding, which means I multiply the insides. And finally, now that I have 1 log and 1 log, I divide. I want to get x by itself. So divide by natural log of 48. I get natural log of 6 over natural log of 48. And that is all I can do to that. Don't try to reduce the 6 and the 48. I know it's tempting, but they're in 2 different logs, so it doesn't work that way, okay? So make sure you just kind of leave it as is. Once you've condensed these kind of steps, you are done after you divide. Okay, so pretty weird, I know, but like I said, once we do a couple, you'll see that they're all the same. So let's keep going. Okay. Once again, I cannot get like basis, so I'm going to take the natural log of both sides. You could, once again, you could use common log. You can use log base too. It doesn't really matter. Okay. Next step says to power down. So I'm going to power down that 5x. Now when I power down on this side, make sure I have parentheses because all of that is being multiplied by natural log of 3. Okay. So now distribute. There's nothing to distribute on the left side. X times natural log of 3 is x natural log of 3. 2 times natural log of 3 is just 2 natural log of 3. Once again, you cannot multiply the 2 and the 3 because one is in a log, one is not. Now I need to get all my x's together. So these two have x's. So I'm going to simply subtract the x natural log of 3 from both sides. Once I have the x's together, I factor out that x. Okay, now this right here is usually the hard part for most people. Once I've factored out that x, I want to clean this up. So I'm going to work on condensing this and this before I divide. You can condense after you divide, it doesn't really matter. I tend to do it here. So I'm going to power up. Let's see, 4 to the 5th. I do not know that. 1024. Let me check here. Yep, 1024. So I have natural log of 1024 minus natural log of 3. Power up, 3 squared is 9. Keep going. Subtraction means you divide the insides. Now, I don't believe that reduces. Let's see, 6, 7, nope, does not reduce. But if it does, of course, go ahead and reduce. Now that you've cleaned it up to 1 log, go ahead and divide by all this junk in order to get x by itself. So I have natural log of 9 all over natural log of 1024 over 3. And it looks messy, but that is a simplified answer. Now, if you are unsure, if your answer matches the back of the book, because we talked about this with inverses, depending on what side you took things over to, your answer could look different. Same with logs. Your answer could look different if you took things over to the other side. So you can always find a decimal approximation. Whoop, that's a really big marker. So I'm going to do that. I'm going to grab my calculator. I'm going to type in natural log of 9 divided by natural log of 1024 over 3. I got approximately 0.377. Now, I'm not looking for that as the answer. I believe your test will say give exact answers, meaning no decimals. It means I want this answer right here that I circled. But if you're checking the back of the book or a handout and you're not sure if your answer is the same, you can go ahead and find a decimal equivalent of your answer and a decimal equivalent of the book's answer. And if they match, you should be okay, as long as it's simplified. Let's try another. Once again, I can't get like basis, so I'm going to power down, or take the log of both sides first. Power down, make sure you have parentheses there, because it's multiplication when you power down. Next step says to distribute. 2x times natural log of 4 is 2x natural log of 4. 1 times natural log of 4 is just natural log of 4. 1 times natural log of 5 is natural log of 5. X times natural log of 5 is just x natural log of 5. Oops, and I forgot my x. There we go. Okay, now I have these two have x's, and I want to keep them as positive as I possibly can, so I'm going to add the x natural log of 5 to the other side. And at the same time, I want to take this natural log of 4 over because it does not have an x. See how I kept my terms positive? You want to make sure they're as positive as possible. Now, it's not always possible, but if you can, keep them positive terms. Okay, so now I factor out that x. And here's the hard part for most people. We're going to clean it up. Our goal is to get 1 log here, 1 log there. So I'm going to power up. 4 squared is 16. Now I know when I add, that means I'm really multiplying the inside of the log. So let's see, I'll get 30, carry the 3, 80, I believe. Same here, when you add, you're really multiplying the insides. And last step is to get x by itself, so I'm going to divide by natural log of 80. And I know that's so tempting to want to reduce the 20 and the 80, but they are two different logs. Leave them alone. This is our final answer. Once again, you could get decimals to kind of check to make sure you're right if you're comparing to another answer. But we're good with natural log of 20 over natural log of 80. Hopefully you see as we keep going. Okay, I've got another one here that these are all very similar. Once you get that process down, you just have to watch for those little mistakes. But you should know what step to do. Very, very logarithmic, logarithmic. It's very step by step, okay? So I'm going to take the natural log. I'm going to power down. Make sure you have parentheses on this side because it's being multiplied by natural log of 6. Distribute. So this side's good. 2 times natural log of 3 is 2 natural log of 3. X times natural log of 3 is x natural log of 3. Okay, now these two terms have x's, so I want to get them on the same side, so I'm going to add that. So add x natural log of 3. Factor out an x. So I'm left with 5 natural log of 2 plus natural log of 3. Now this is the step that confuses people. We're going to clean it up so that we get 1 log here, 1 log there. I'm going to power up. 2 to the 5th is 32. 3 squared is 9. Keep going. Addition means I multiply the insides. So let's see, I'll get 6, 96. And finally, the goal is to get x by itself, so I need to divide by natural log of 96. So I get natural log of 9 over natural log of 96. Boom. That's my exact answer. Can't touch it in the 9 or 96. Can't reduce that. Okay, they're in 2 different logs, so there we go. Hopefully you're starting to catch on to the process here, because like I said, you should study and know the steps, and then it's just a matter of watching your little errors. Let's do another one, and then I think we have a U-try. Yep. So one more. Let's take the natural log. Power down. Make sure you have parentheses because it's being multiplied. Oops, natural log of 7. Distribute. So I have 3x natural log of 7 plus 2 times natural log of 7. X times natural log of 5. 2 natural log of 5. Okay, this has an x, this has an x. So they're both positive, so I just need to pick a side here. So I'm going to subtract the x natural log of 5. Which means I need to subtract the 2 natural log of 7. Factor out that x. Okay, now I need to clean up, so I'm going to power up. Okay, and we might need a calculator for this because they might get gross. We might get some fractions and all that. We'll see. So I want 7 to the third is 343. Over here, power up, I have natural log of 25. Oh, excuse me, minus natural log of 49, right? 7 squared. Okay, subtraction means I divide the insides. So I have 343 divided by 5. That does not reduce, but if it did, you would go ahead and do that. Same over here, divide the insides. Oh, 49. That does not reduce either. Now finally, divide by that natural log of 343 over 5. I'm going to put parentheses on my input. Doesn't really matter. There we go. Beautiful. It looks messy, I know, and it is, but it is correct. We're good. We're simplified. We have the answer. If you were unsure, because this one could look very different compared to a neighbor or the back of the book. So once again, you can always find a decimal to make sure you are equivalent. But I will ask for exact answers, which means no decimals. Okay, you try. So go ahead and work this one for a minute. We obviously can't click in, but I'm going to give you a minute to work it, and then I'll go over it in a minute. Okay, let's start going over it. Take the natural log of both sides. Then I'm going to power down that x, power down the 2x plus 1. Make sure you have parentheses because the next thing we want to do is distribute. Okay. Then I underline my x terms. I want them all on one side, so I went ahead and subtracted 2x, natural log of 3. Factor out the x, and then it's just a matter of cleaning it up. I powered up, and the subtraction means you divide the insides. And then finally, x times all this junk, so you have to divide by that junk. We have natural log of 3 over natural log of 4/9. All right. I just want to show you one more tricky one before we're done, because we will have a handout that will have one or two of them like this on here. Okay, it's when we have 3 exponentials. Okay, we're going to still take the natural log of both sides, so the whole side. Now, before I can power down, I need to split this up. That's multiplication going on. So remember, to split that up, that's really addition of the logs. And that's the trick to this problem, that I have to split up that multiplication into addition. Now I can power down Same over here. Let's distribute. Okay, now I need all the x terms together. This one's kind of a tricky one because there's no really way to avoid some negatives. If I took this over, then this would have to be negative. I could take these two over, they would be negative. I'm going to try to leave this term positive, so I'm going to take these two over. There's no nice way to do this one. Okay, now that I have them on the same side, factor out an x. Okay, now I need to work on cleaning this up, so I need to power up. So let's see, that'll be natural log of 25 minus natural log of 2 minus natural log of 9. Okay, let's keep going on the cleaning up. These two being subtracted means I divide the insides. So it's 25 over 2. Oops. I still have the minus natural log of 9, one step at a time. Now, when I divide those, it's the same thing as subtraction. I'm going to do division. You can use your calculator, but remember you're dividing by 9, which is the same as multiplying by 1/9, the reciprocal. So I'm getting 25/18. And that does not reduce, but if it did, we would. And finally, divide by that natural log to get x by itself. So I have natural log of 3 all over natural log of 25/18. So that one's about as tricky as we can make them. And you've got that extra step of splitting up that log. So it's kind of a really challenge one right there. Most of them are like the others. Okay, tonight you have homework 12 through 20. Like I said, if you're unsure if it matches the back of the book, and I think some of the book doesn't clean them up as much, if I remember correctly, of course you do, because we will on the test. You can always check your answer with the back of the book by finding decimals, but you need to clean it up to be 1 log divided by 1 log. Okay, that's how every problem must look. If you're unsure, come see me. I'm in for morning tutorials, so come ask for help. Good luck.